Hey guys, welcome back to the Engineered Angler. I'm still messing around with the clear coats and trying to come up with something good that I can share with you guys. But in the meantime, for this week, I don't want to build a lure. I want to build a lure mold rotating machine that I can design so that it'll rotate the mold in this direction and in this direction all at the same time. The idea is if I can get that 2-axis rotation going, I'll be able to pour a hollow lure. So that means a lure that I can drop a weight in, a knocker weight, or BBs, and I can modify the weight after it's cast. Let's go ahead and do a concept drawing on the dry erase board. So it's going to consist of 2 wooden frames, one inside the other, one rotating on the horizontal plane and the other one rotating on the vertical plane. If that's the bigger outside frame, it'll be attached to some kind of post or stand that'll act as a pivot point. So the outside frame will have its pivot axis like so. And we'll have some bearings embedded either on the frame or on the actual stands, or both. I haven't decided yet. And the inside frame will be small enough for clearance to rotate. And it'll rotate with its rotational axis attached to the outer frame. Now the real trick to this is getting both of them to rotate at the same time and synchronize, so they're both rotating at the same rate. Now I want to rotate them with a motor, so I'm going to hang a motor over here somehow. I'm not exactly sure. I'll have to make some kind of mount for it. Now I know a lot of folks have done these by hand, sort of rotated them with a crank or just spun them by hand, but I don't want to have to do that. I'm probably going to be using materials that are going to take hours to set, and I'm not going to stand there for hours doing this. Now, most of the ones I've seen have used gears to transform this horizontal rotation from the motor to the vertical rotation that needs to rotate the inner frame. And that means a gear here, a pinion, a rod going up with a pinion gear meshed to another pinion gear and brought over here to another pinion gear, and that is meshed to a horizontal gear there. And that's just way too complicated. So I'm going to do it with an elastic belt, a belt that actually has tension and can transform this horizontal rotation to vertical rotation. The way it'll do that is I'm going to mount a fixed pulley here that the shaft will run through, and it'll be mounted to the same thing that the motor's mounted. So it'll be stationary. Then I'll have a pulley up here, and this will just be an idler pulley. There'll be 2 of them, one in front, one in the back. And then I'll have the same kind of pulley that I have here, right here. They'll be the same size, so there won't be any change in rotation speed. And I'll just run an elastic belt right along here, around the idler pulley, and down to this pulley here. So the drive shaft up here will be attached firmly to the inside and rotating up here. And then this drive shaft will be attached firmly on the outside frame, but spinning through the stand and through this pulley right here. Now, I haven't really drawn up a formal set of plans. I just did a sketch with a few notes and some dimensions, and I'll post that somewhere in the community section or something. Anyway, hopefully I won't screw any of this up, and we'll end up with a really cool rotator. Right, so the idea is that the bigger square is going to spin this way on the horizontal axis, and the smaller frame is going to spin on the vertical axis. We're going to be using this little motor here. It's a 100 RPM motor, and I've got some little V-groove pulleys. One will go up here. This pulley will be fixed to the actual outer frame. That pulley will be fixed to the inner frame. And then we'll have these little transition idler pulleys that will take the belt around and change it from horizontal rotation to vertical rotation. That way, as this thing rotates, it rotates this guy, which rotates the inner frame. It's a little bit of a brain teaser to look at, but pretty sure it's going to work. And to mount these guys, I need a little tab that's going to stick out a little bit. So I'm going to make it out of this scrap piece of aluminum. And I'll need two of them. So there's one here and one up here. You know, you would think aluminum would be easy to cut with tin snips, but it's not really that easy. And it'll get mounted something like that. Then I'll have a hole drilled in here for these guys to be mounted on there. Just need to make the other one, and I'll put a little tube in the middle to keep these from getting squeezed. So my next step is to go ahead and glue this down. I've sanded a really coarse surface on this so that the glue will hold, and this bolt is really just there for alignment purposes. And I'm going to use some JB Weld, this 2-part fast setting epoxy. Alright, so we're close to being able to assemble this thing, and you notice I got it painted, and don't judge me on the colors. I know it looks like Barbie's Malibu lure spinner or something, but part of the challenge I gave to myself when I started building this was to try to use everything I could from what I already have in the shop, which is a lot. There's a lot of junk in here. And so far I've only had to buy the specialty stuff, the motor, the bearings, and the little pulleys. Everything else has been just laying around here, including the paint. And I was going to paint it all black, but I ran out of black paint and it ended up white and red somehow. So now I'm just going to start putting in the hardware. This pulley's already installed. You saw me glue that in. Now I'm going to put in these bearings. These two on this edge. Just press in. And then the opposite edge and the other edge. Now I need to put the pulleys in. And I'll put a nylock nut on this end so I can be sure it's not going to come loose. Alright, no slop, and they spin nice and freely. So the inside frame is going to be carried by the bearings. The bolt on top is also going to have the pulley, so it's extra long. So I have to put that one in first. And it has to be fastened against the frame, so this bolt will spin with the frame. And I'll put a nylock nut on this too. Then I'll have to tighten it down to the right length on the outside and snug it up against the inner frame. I think that should do it. Now I need to slide this bolt in and set our nut on this one. and we should get some pretty nice easy spin off this. Now we need to mount the pulley on here, and I don't really want this protruding, so I'm going to cut this one too. There's some set screws on the shoulder of this pulley, so I'll just file a flat spot for those things to grab. And I just slide this on and align it with the flat spot and tighten it down. And there's another one on this side, so I'm going to tighten that one down too. All right, that spins pretty nice. Again, I got to seat the bearings for this thing, and I'll go ahead and put together a parts list, and I'll put it all in the description and have everything I can on the Amazon, because I did get everything out of Amazon except for all the scrap wood, obviously. And on this one, it's a little different from most of them. I actually need to have something in the middle there so the bearing doesn't bind up. And all this is a piece of this mechanical pencil body that I just cut off. So it'll wedge up against the inner race of the bearing, and then I can put this nut on here and actually have two nuts so I can get the separation right. Tighten that one up against there. This one will have a little nylon washer as a friction reducer, and this thing slides right in here, I think. All right. You know, I should have probably drawn up some plans that I could follow instead of just doing a concept drawing on the dry erase board. Now this end gets attached to the motor, and it just goes on with the set screws in the hub of the pulley. So I'm just going to align the set screws with the flat spot on the motor shaft. All right, it looks like a modern art piece of sculpture. All right, I've taken this piece of scrap aluminum, cut a piece out of it, and made this little tab to be able to mount my little electrical connector. And I'm going to put this right here. And this will be mounted right there, and the wires will go up and connect to the motor. All right, I've got it mounted, and I've got the power controller up here. This is just a little 12-volt dial-up power controller. Goes from 3 volts to 12 volts. And it occurred to me, I haven't even tried the motor. I did all this and I didn't even try the motor, so let's just hope it works. Let's see what it looks like. I should probably clamp it down. Let's see how it does. All right, that's slow. Oh yeah, I'm glad I got it clamped down. It does want to wobble. One of the things I had really dealt with was the clearance of it. If it goes around with this thing at a 90 and it looks like it just barely hits. So I'm going to stick another like 3/4 inch piece of wood underneath the main platforms, and then we'll do the connection with the belt. Then we'll get both rotations. So I should be able to put them together pretty evenly. Set this flame really low. Let's see how this works. Hopefully this sets. All right, that looks pretty good. Stretch it. All right. All right, let's try it again. Now we should get rotation with both frames. At this point I realized I mounted the pulley on the wrong spot. It should be mounted on the motor frame and not on the outer wooden frame. All right, so I've done a lot of modifications. Let me walk you through what I've done. So the majority of the modifications are right here, right where the motor is mounted. This whole assembly had to be changed quite a bit. That first thing I had to do was remove the pulley from this outer frame and attach it to the aluminum plate here that is part of the mount for the motor. And the way I mounted it was to rivet it through. The next thing I did out here is to reinforce this leg with another plate, wooden plate right here, just like the original one on the inside. And then I added another aluminum plate on the outside and modified my mount so I can use the threaded holes that are in the motor itself and just used some machine screws to mount it right to this plate. I did all this because the tension on this thing, it was putting a lot of load on the motor, and I didn't realize that was going to happen because I thought this pulley would support it. There is actually a load due to this thing pushing downward on the frame, which pushes downward on the drive shaft, which in turn kind of wants to move the motor up and down as this thing rotates. So I had to do a little bit of a separation so there wasn't a cantilever. This is supported between the two plates. And then I made sure that the drive shaft was fixed to the outer frame by using this little flange coupler. And that looks like this. And you can see it's attached to an aluminum shaft. And I bought a little bag full of these little 6-inch, 1/4-inch diameter aluminum shafts. And that's what I made the drive shaft out of. You can see right here. And it just goes through this pulley unattached and attaches here using that blue coupler. And I had to buy a couple of those too. And I added this mold vise here to hold the mold while I'm spinning it, because I had to have some way to hold it. And all I did was run some 1/4-inch all thread through the inner frame here, and it's countersunk in here so it doesn't come through and get in the way of the outer frame. And I just got some nuts on it that tensions them up, and I've got these nylon butterfly nuts here so I can adjust where the jaws are in line with the center of this frame, so everything's balanced when I'm running it. And you can see I've got a mold in there. I've been doing some testing on casting, and this one's about ready to be opened up and see how it came out. But before I do that, there's one more thing that I want to show you. So one thing that I discovered is that it actually pulses, right? It hurries up right there and then slows down, hurries up. And that's because it's a little heavier up here where this pulley and these two pulleys and bolt are. So that's another 55 grams or so. And I want to try to reduce that, because what I'm finding is that the slower you can go, the more evenly spread out the resin is. And I'll show you that in a couple of mock-ups I've already done. And that little bit of a surge that it does, I'm afraid, is going to cause one side to be thicker than the other. So let's see what we can do about it. So I cut a little piece of galvanized steel here so that it's right at 52, 53 grams. That should about balance it. And I'm going to stick this about halfway between the center bolt and the edge here on the side opposite from those pulleys. That should do it. Let's see if it changes. All right, let's try with a little more weight. Here's a thin washer, a little square washer that'll fit right back here, and we can just fasten it in place. All right, that's perfect. There's no surge at all now. I'm pretty happy with that. So I'm gonna leave it just like this. It can really go super slow and have no surges. Really like that. Actually, the motor sounds a little happier, and it just seems to be moving a little more smoothly anyway. So let's see what it does at high speed. Wow. Okay, I'm pretty happy with that. There's no vibration. It doesn't want to move. I don't even have it clamped down or anything. That's pretty cool. We won't be running it that fast. So I'm going to go ahead and leave it just the way it is. No more painting, no more messing around. I just want to start casting some lures. All right, I've got my latest experiment in there. I've been doing a little bit of experimentation with that thing with a couple of different materials to see what kind of results I'm getting. It's pretty promising, but I'm tweaking my ability to get actual lure that can be used. So let me show you a couple of examples of the results I've been getting. So here are the two first ones I cast. And if you take a look at this was the very first one I cast. And you can see it looks very translucent. It's definitely hollow, and I cut it in half. Now the first thing I needed to do before I cast it is to estimate how much volume of the casting resin to use. Now I used about half what I normally would use for this lure, but the walls came out really thin. And if you look closely, you can see that a lot of the material went to the ends. The head and the tail are sort of solid. And that told me that I was rotating it just a little too fast and pushing everything out to the outside. This was my second attempt. just a little more material, and you can see it's nicely even, distributed pretty even. It's a little thin here, but that just means I need to add a little more material. But this one is almost a usable model. I didn't put any hook hangers or anything. Those I'm going to shape out of wire and just embed them so they're sticking in the casting itself. So this thing should have long since been set. So let's go ahead and undo this, pull it out, and see how it came out. All right, let's check it out. All right, this thing fell right out. And this is just a little piece of tube that I'm using to block the sprue so it doesn't leak all the stuff out, because I haven't really made molds specific to doing this rotational thing. The nice thing about putting that tube in there, it leaves me with a nice port to be able to drop my BBs in. This feels pretty nice. It's nice and solid, but you can hear how hollow it is, but feels pretty strong. I'm gonna go ahead and just take it to the saw and cut it in half. Let's see how the walls came out. That looks pretty doggone good. It's amazing what a sheen it gets on the inside. I wonder why. On the outside, it just gets, I guess, whatever the inside of the mold gives it, but the inside is just really shiny. So it feels like the wall thickness is nice and thick enough to deal with any kind of bite or impact on rocks. Yeah, it feels pretty tough. I think I'm gonna go ahead and on the next one, make it a little thicker. I'll add just maybe 10% more material just to be sure we got a nice wall thickness on this thing. And this one, I'm including the little wire loops I'm gonna make the hook eyes and the tie-on eye out of. This way, they'll just be embedded in the casting itself. And this is the regular casting resin I use just to cast solid lures. That means very little working time. I've got to really kind of rush to get this filled and then get it over here to the machine and get it clamped down so it won't leak too much. Hopefully it doesn't leak. Like I said, slow is better. And to help me with that, I got this little digital control. It wasn't much more expensive than the original one I had, and it's a lot more sensitive, and I can actually see a readout so I can be a little more consistent on where I set it. So that should do it. I'm going to go ahead and get back to this in about 20 minutes. Should be able to demold it. All right, the stuff on the bottom of the mixing cup is rock hard, so we should be ready to turn this thing off. Let's see how this came out. Hopefully it's fully set. It looks good. All right, it looks pretty good. But it still came out with one side a little thicker than the other. So I made a modification to try to address that. I modified the machine a little bit. I reduced the size of this pulley. This was the original one, so I reduced it by half. This way, this is spinning twice as fast as the outer frame. And the reason was that every time I cast, I would get one side that was really thin. You can see my fingers through it. And one side that was pretty normal. And you can see the ends would get a little more material than they really need. What I realized was as this thing was turning, since they were turning at the same rate, it was doing this weird sort of figure eight dance where one side of the mold was always slightly facing down and the other one never faced down. It's better if I show you. Keep an eye on that little red straw as this rotates. You'll see that that straw never points down. So that side of the mold never actually points down, and therefore that side is always cast a little thinner. So you ended up with one fat side and one really thin side. But now with this, it actually makes a perfect casting. And I'm super happy I figured it out, and a little bit disappointed I hadn't thought of it before it actually was a problem. All right, with the clay out of there, let's drop some stainless steel balls in there and see what kind of noise we can make with it. Oh yeah, that's gonna be really cool. Maybe just one ball next time. Anyway, I'm gonna go ahead and patch that hole, put some hooks on it, take it down to the water, and get a little bit of footage of this thing, see how it walks the dog. But stay tuned for a lot more of this experimentation. I'm going to be experimenting with some flexible polyurethane casting resin. That stuff is really flexible and I think will make really good frogs. But I've got to find some of those double hook frog hooks to be able to use it with it, and I've got to make a frog and a mold. So until then, stick around for some water footage and I'll see you guys on the next video.